You will never win the lottery. I'm not being mean. I'm being mathematical. And those are two very different things. Though in this case, they feel exactly the same. Here's the thing. Most people look at the lottery and think, someone wins every week, so why not me? N. That sentence sounds reasonable. It is also one of the most statistically broken thoughts a human brain can produce. And today, we're going to figure out exactly why, using the actual tools of statistics. Not the boring textbook kind, but the real, sharp, slightly terrifying kind that explains why you make bad decisions, why your favorite chart is lying to you, and why a goat on a game show changed mathematics forever. Trust me, sticking around for this is going to save you a lifetime of terrible bets. Go ahead and subscribe right now so you never miss our weekly breakdowns of how the world is secretly playing you. Okay, ground floor, let's start with what statistics even is. You've got data, a pile of numbers. Could be anything: lottery ticket sales, shark attacks, the temperature in Phoenix in July, how many hours of sleep college students get before an exam. Statistics is the science of making sense of those piles. It's pattern recognition for a universe that really doesn't want to be understood. But here's the trap. The universe also loves to mess with you. And it does that through something called variance. So what is variance? Great question. I'm glad you have a brain. Imagine you're throwing darts. Not because you're good at darts. You're not. But imagine you throw 100 darts at a dartboard. Some land close to the center. Some land embarrassingly far from it. The average of all your throws might be pretty close to the bullseye. But that average is hiding something, because 2 of those darts hit the wall. Variance is how spread out your throws are. It's the difference between mostly fine and wildly unpredictable. Low variance means your throws cluster tight. High variance means they're everywhere. And this matters enormously because lottery jackpots are designed to have absurdly high variance. The prize is gigantic. The probability is microscopic. And the distance between those two things, that gap, is exactly how they make money off you. Let's talk numbers. In a standard Powerball lottery, your odds of winning the jackpot are roughly 1 in 292 million. The population of the United States is about 335 million. So statistically, it would be easier for a random American to be the only person in the country who didn't buy a ticket and still come closer to winning than to actually win. That's not a joke. That's just the math being honest in a way that is kind of devastating. But wait, people do win. Every few weeks, someone wins. So isn't that proof it's possible? Yes. And this is where variance bites you. Of course, someone wins. You're selling hundreds of millions of tickets. If you flip a coin 300 million times, you're going to get some insane streaks. 12 heads in a row isn't magic. It's just what happens when you run enough trials. The winner isn't special. They're just the one dart out of 292 million that happened to hit the center. And you are almost certainly not that dart. Here's the deeper concept: expected value. This is the mathematical version of, is this a good deal? You take every possible outcome, multiply it by its probability, add them all up, and you get the expected value, what you should expect to get, on average, if you played this game forever. For a $2 lottery ticket where the jackpot is $300 million, that sounds amazing. Until you do the math. You take 300 million, multiply by 1 in 292 million, and you get just over $1. Your expected return on a $2 ticket is about $1. You lose half your money every single time. On average. Over your lifetime. Every ticket. And casinos know this. Sports betting apps know this. Everyone in the gambling industry has done this math and built their entire business model around it. The house doesn't win because it's lucky. The house wins because it set the expected value in its favor before the game even started. So the lottery isn't really gambling. Gambling implies some skill might help. The lottery is just a very expensive math lesson. Most people just don't take the class. Okay, so variance tells us the lottery is a trap. But here's the thing. Variance shows up everywhere, not just in games designed to take your money. It shows up in medicine, in sports, in business, in literally every decision you've ever made under uncertainty. And to understand why, we need to go one level deeper. Because the reason variance matters, the reason statistics exist at all, is probability. And probability is weirder than you think. Not weird like quantum physics weird. Weird like your brain is confidently wrong about it every single day. Weird like a game show with a goat changed how mathematicians think about information. That's where we're going next. But first, one more fact about the lottery. The states with the highest lottery ticket sales per capita are consistently the states with the lowest median incomes. People who can least afford to lose $2 are the most likely to spend it on a 1 in 292 million shot. That's not a coincidence. That's variance being weaponized. And statistics is the only tool that can show you exactly how that weapon works. Okay. Probability. You think you get it. You don't. Nobody does, the first time. Even professional mathematicians get it wrong when it's dressed up in the right costume. Here's a classic. 3 doors. Behind one of them, a brand new car. Behind the other 2, goats. You pick door number 1. The host, who knows what's behind every door, opens door number 3 and reveals a goat. Now he asks, do you want to switch to door number 2 or stay with door number 1? N. Most people say stay. Or they say it doesn't matter. It's 50-50 now, right? N. 2 doors, 1 car, coin flip. That's what your brain tells you. Your brain is wrong. You should always switch. Always. And your probability of winning if you switch is 2/3, not 1/2. This is the Monty Hall Problem, and when it was first published in a magazine in 1990, nearly 1,000 PhD mathematicians wrote in to say it was wrong. It wasn't wrong. The mathematicians were. This is not a flex. It just shows how badly human intuition breaks under probability. Here's why switching works. When you first picked door 1, you had a 1 in 3 chance of being right. That means there's a 2 in 3 chance the car is behind one of the other 2 doors. Now the host removes a wrong answer from the other side. He didn't remove the car, he knows where it is, he'd never do that. So that 2/3 probability? It didn't disappear. It collapsed entirely onto door number 2. Think of it this way. Imagine 100 doors. You pick one. The host opens 98 of the remaining doors, all goats, and leaves one closed. Do you switch now? N. Of course you do. You'd be an absolute fool not to. The logic is identical with 3 doors. The numbers just hide it better. This is what probability does. It is not always intuitive. It rewards people who slow down and count carefully, and it absolutely destroys people who go with their gut. And this matters for everything: medical testing, courtroom evidence, financial risk, public health. Your gut is not a statistics calculator. It is a story machine. It finds patterns, builds narratives, and confidently skips the math. Which brings us to something even more dangerous than bad probability. It brings us to correlation. So here is a completely real statistical fact. In the United States, ice cream sales and shark attacks go up at the same time every year. The numbers move together. If you plotted them on a graph, they'd practically hold hands. So does ice cream cause shark attacks? Obviously not. But this is correlation. 2 things moving together, and your brain desperately wants to turn it into causation, which means one thing causing the other. The actual explanation is a 3rd variable, summer. It's hot. People buy ice cream. People also go to the beach. Sharks are at the beach. Ice cream had nothing to do with it. This sounds dumb when I say it out loud. But the same logical error shows up in serious research all the time. Studies that show people who carry lighters are more likely to get lung cancer. Studies that show counties with more churches have higher divorce rates. Studies that show kids who have more books at home do better in school. In every one of those cases, correlation is real. Causation is complicated. and the headline almost never tells you the difference. Marketers know this. Marketers love this. They take two correlated things, put them next to each other in an ad, and your brain does the causation leap for free. People who drink our smoothie are healthier. Are they healthier because of the smoothie? Or did healthy people just happen to be the ones who bought it? And the data doesn't say. But the ad sure implies it. And this is where manipulated graphs come in. Oh, we need to talk about graphs. Because the way data is visualized is one of the most powerful and least discussed forms of deception in everyday life. Here's the move. You want to show that your company's sales went up. They went up by about 3%. 3% is fine. 3% doesn't look impressive on a graph if the y-axis starts at 0. So you start the y-axis at 97. Now your line shoots dramatically upward. Same data. Completely different story. This is called a truncated axis. It's technically not lying, but it is absolutely manipulating you. And it's everywhere. News broadcasts, political ads, pharmaceutical marketing, tech company earnings reports. The moment you learn to spot it, you cannot unsee it, and you will feel genuinely betrayed by like 70% of every chart you have ever trusted. Okay. Stop. Because here's the moment where I need you to actually feel something. What? There are more possible arrangements of a standard 52-card deck than there are atoms in the observable universe. Every single time you shuffle a deck, if you do it properly, you are almost certainly producing an arrangement of cards that has never existed before in human history. Not since cards were invented. Not ever. That specific order in your specific hands is new to the universe. That is what randomness actually is at scale. Not chaos. Not disorder. It's the combinatorial explosion of possibilities so vast that repetition becomes almost impossible. And statistics is the science that looks at that ocean of randomness and finds the islands of pattern floating inside it. That's not just math. That's actually insane. Here's where it gets personal. Because everything we've talked about, the lottery, the Monty Hall problem, the ice cream, and the sharks, all of it connects back to one of the most psychologically damaging statistical illusions that humans fall for. And it has a name, survivorship bias. You've heard the advice. Follow your passion. Take the leap. Look at Elon Musk. Look at Steve Jobs. Look at that 22-year-old who dropped out of college and built a billion-dollar company. That advice sounds inspiring. It is also statistically incomplete in a way that should make you at least a little angry. Here's the thing. For every Elon Musk, there are thousands of people who took the same risks, worked just as hard, believed just as fiercely, and failed. Quietly. With no documentary, no TED Talk, no magazine cover. You don't hear about them. Not because they don't exist. They absolutely exist. And there are way more of them than there are Elons. You don't hear about them because failure doesn't make good content. Survivorship bias is what happens when you only study the survivors. You look at successful companies and ask, what did they have in common? And you find all these patterns: great leadership, bold vision, innovation culture. But you're only looking at the ones that survived. The failed companies had all those same things. You just never studied them because they're gone. This is huge in medicine. In the 1940s, the US military was trying to figure out where to add armor to their bomber planes. They looked at planes that came back from combat and mapped where the bullet holes were. Most damage was on the wings and fuselage. Very little was on the engines. So obviously reinforce the wings, right? Wrong. Abraham Wald, a statistician, pointed out the error immediately. The planes they were studying were the ones that came back. The bullet holes they were seeing were in the places where a plane could take damage and still survive. The engines, barely any bullet holes there, because planes that got hit in the engine didn't make it back. You needed to armor the parts with no bullet holes, because those were the deadly spots. That is survivorship bias, and it is everywhere. Investment funds quietly dissolve the ones with terrible returns and only show you the average of their surviving funds. Movie studios greenlight sequels to hits and hide the flops. Sports coaches remember the dramatic play that won the game and forget the exact same call that lost the previous one. Statistics is not just about counting things. It's about knowing what you're not counting. The absence of data is also data. The planes that don't come back are the most important planes. Now zoom all the way out. We started with a $2 lottery ticket and a 1 in 292 million shot at a jackpot. And we followed that thread all the way up. We found variance, the spread of outcomes that hides risk inside reward. We found expected value, the math that tells you what a deal is actually worth when emotion gets out of the way. We found the Monty Hall Problem, proof that intuition and probability are not the same sport. We found correlation and causation, the oldest trick in the manipulation playbook. We found truncated graphs, the art of technically not lying. And we found survivorship bias, the ghost data that shapes decisions in ways most people never see. All of it is statistics. All of it is the same toolbox. And this toolbox is not just for mathematicians. It's for anyone who reads a headline, sees an ad, gets a medical diagnosis, makes an investment, or looks at a success story and wonders if they could do the same. Statistics is the language of uncertainty. And we all live in uncertainty constantly, whether we speak the language or not. The people who speak it, they make better decisions. Not always. Nothing is always. But systematically, over time, in the same way that the house wins at the casino, they come out ahead. They see the goat behind the door before it's revealed. They ask about the planes that didn't come back. They look at the ice cream graph and ask, what else went up in summer? That is what statistics actually gives you. Not certainty. Never certainty, but a dramatically sharper relationship with uncertainty. A way to be wrong less often, and to know when you're probably being deceived. Now, here is the open question, the one nobody has fully answered. We have incredible statistical tools. We have computers that can find correlations in datasets with billions of data points. We have machine learning models that can predict behavior with genuinely scary accuracy. And yet, we still don't fully understand how to tell the difference between a pattern that means something and a pattern that's just noise at a really convincing scale. At what point does a correlation become evidence of causation? We have tests for this. We have p-values, confidence intervals, randomized controlled trials. But even those tools have limits, and the history of science is full of findings that passed all our statistical tests and turned out to be wrong. Not fake, just wrong. The math was right. The conclusion wasn't. That gap between the math being right and the conclusion being right is where modern statistics lives. And it's where the next generation of researchers, thinkers, and maybe one of you will spend their careers. You will never win the lottery. But you might just figure out how the game is rigged. And that's worth a lot more than the jackpot. If state-run lotteries statistically prey on the people who can least afford them, is it ethically justifiable for governments to keep running them under the guise of funding public schools? Tell me your thoughts in the comments below, and don't forget to subscribe if you haven't already. We've got plenty more illusions to shatter.